Hi students, so here we are with another video where we have yet another question from Newton's laws of motion and friction, and this too is a question from Pathfinder Physics and very important question, and let's try to analyze what the question is saying and how to solve it. So here we have a block and it is resting on a rough floor. They have given the coefficient of friction between the block and floor as 0.5. Now you can see that there is a uniform massive rope whose total mass is 2 kg and length is 4 meter. The total length of the rope is 4 meter. Now you can see it is curved. But that doesn't mean that it is loose or slack, because when it is massive, tension will vary from point to point, and tension in a curved rope is always taken tangential. If it is a straight, then nothing to worry, it will be along the rope only. But if it is curved, it will be always tangential and a pulling force, right? So tension will be always tangential. Now this person, he is holding the top end of the rope, and they have also given the mass of the block as 7.5 kg. This block is of 7.5 kg. The block is found to be static, but they did not mention that it is a case of limiting equilibrium, because they did not say that the block is about to move. So that means the friction over here will be static. If it is there, it will be static, right? We cannot say that it will be limiting or F max, because they have nowhere mentioned it. They have given the value of G as 10 meter per second square. The question being asked is, what angle we have to find? The upper end must be pulled at an angle that is closest to how much? With respect to horizontal, what angle are you pulling it? And they are also asking in the second part, what is the frictional force between the block and the ground at this particular instant? So let's see how to solve this particular question. Well, here, as I said, this top end, if I mark this end as B and this particular end as A. Now the force which will be acting, pulling force, that will be the tension at point B. Let's call this tension as TB. Now this tension, it will have two components. This is the horizontal component at the point B, and this will be the vertical component. So the force is applied at what angle with respect to horizontal they are asking. Let's take this particular angle over here as phi. So in question we have to find phi. Now due to this, the block is getting pulled towards right, so it has a tendency to move towards right, but actually it is not moving. So there will be a friction force, which will be obviously static friction, which will be backwards. Now the system is in equilibrium, so net force will be 0. One more force, if you see, for the rope, its weight, the total weight of the rope, we can show on the center of mass. So this is the weight of the rope. Mass of the rope is given 2 kg, so mg will become 2 kg, so 20 Newton, right? Now at the point A, the rope is horizontal. So if you see by free body diagram, what we can see here, for the block we have Fs. This side we have tension at the point A, the normal exerted by ground, and this is weight of the block mg. Now they have given the mass of the block as 7.5 kg, so this will become 75 Newton. So for equilibrium we can say static friction will be equals to Ta. So tension at point A is horizontal. Now if you go by the FBD of the rope, so as I said, this side we have horizontal component, this side vertical we are showing, this is the point B. Now point A, the tension on the rope will pull it backwards, TA, and we have the weight of the rope acting downwards, which is 20 Newton. So what can we say for the two cases which I have shown in the diagram? You can see that the friction force is equals to TA, and since the rope is also in equilibrium, so horizontal forces will be balanced, so we can say that TA will become equals to THB. But TA is also equals to Fs, that means THB we can say will become equal to Fs. So horizontal component at point B will become equals to the friction force Fs, and vertically if you see, TVB will be balancing the total weight which is acting downwards, so we can say TVB will balance 20 Newton force. So this is what we should be clear in the beginning itself. What are the expressions we are taking? The tension at point A will be equal to the static friction on the block, and tension at point A is also equals to the horizontal component of tension at point B, because the rope is also in equilibrium, and vertically the tension at the highest point B will be balancing the weight of the rope, which is 20. Okay, the total length of the rope is given 4 meter, and you can see at this particular position it is at a height, the point of suspension, this where the person is holding it, this is at a height of 2 meter, right? So let's see what are the values of Fs and what angle phi here the tension will make with the horizontal, that too we have to find. So let's proceed. So what we can do is, since tension will vary from point to point, we can redraw the rope. Now at the point A, this horizontal line, let's take it as y equals to 0. Vertically we are taking as y axis, horizontally we are taking as x axis. This point B we just saw, tension at point B will be expressed as under root of horizontal component square plus vertical component square, and we saw that horizontal component was balancing friction, so Fs square, and vertical component was balancing the weight of the rope, which is 20. This is what we can say. And here the angle which I said is phi, so by trigonometry tan phi will be vertical component by horizontal component. So vertical component at point B by horizontal component at point B. So vertical component which is 20 and horizontal component which is Fs. So these are the things that we can say. Now apart from this, what was the tension at point B A? We saw that tension at point A, the lowest point where y was 0, this tension was equals to Fs. So what we do, we go to a general height. If I go to a general height y, and if I take a small element, over here whose length is say dl. Now this small element will be pulled from both sides. The lower end will pull it downwards. So let's call this tension as T. At a height y, this is the tension. And when we see this end, upper end, tension over here will change by a small amount. Why small amount? Because the length itself is very small. This element is very small. So tension at y height will be taken as t, and when you go further dy height above, then the tension becomes t plus dt. Now tension is continuously varying, and you can see at the point B the total height becomes how much? 2 meter at this point B. Clear? Now if you see this element which I have taken at a general height, so if I draw a tangent, let's take the angle made by the tangent at this point as theta, where the height is y. Now here, what all forces, we can treat this element as if it is kept on an inclined plane, and what all forces will act, we know. This side we have t plus dt, pulling it up. Downwards we have t, and the weight component, it is just behaving like an inclined plane, so we can say there will be a weight component downwards. If its mass, this element, let's take its mass as dm, so this will have mg sin theta, I hope you remember, so dmg sin theta. Now since every element is in equilibrium, this will be also in equilibrium, so we can say upward and downward forces will balance, means t plus dt will be balanced by t plus dmg sin theta. So from here t cancels, so we get dt. Now what is dt? dmg sin theta. How to get dm? Very simple. I have taken the length as dl. So what is dm? dm is total mass of the string divided by its length, total length, into dl. So what is the total mass of the string or rope? You can see in the question it was mentioned 2 kg and length is 4 meter. Okay, so if I substitute all SI units, so this will become dl by 2 kg. Okay, so dl by 2 kg. So here we have dl by 2, putting the value of g as 10 and sin theta. Now what else we can see from here? You can see that we have taken this angle as theta. So if you take this angle as theta, you can see that this length is dl, this angle is theta, this length is dy. So can I write dy, the vertical height will be dl sin theta. So if dy is dl sin theta, so dl sin theta being dy, so 10 by 2 becomes 5 dy. So dt is 5 dy. Now if dt is 5 dy, we have to integrate to get the value of whatever is being asked. So let's quickly see how we can find the value. Now dt being 5 dy, if I put limits of integration properly, so dt is 5 dy, integrating, y is 0 here and here y at the highest point is 2. So we have to integrate y from 0 to 2. And tension is to be integrated from lower point TA till TP. That's it. So what do we get this side? TB minus TA will become 5y, y is 2, which is 10. So TB minus TA is this. Now what is TB? TB is under root of Fs square plus 20 square. So we can take it here. Under root Fs square plus 20 square means 400. This will be equals to, take TA on the other side. What is TA? TA is Fs. So 10 plus Fs. Now we can very easily calculate Fs. How? Just square both sides. So Fs square plus 400 under root is equals to 10 plus Fs. So let's see. When you square both sides, so we get Fs square plus 400. This side we will have Fs plus 10 whole squared, which will become Fs square plus 100 plus 20 Fs. So from here Fs square cancels. So we get 20 Fs is 400 minus 100, 300. So 400 minus 100, 300 and divided by 20. So 30 by 2, which gives 15 Newton. So Fs is 15 Newton. What else? We saw tan phi is 20 by Fs. Tan phi is 20 by Fs. So the string at the topmost point makes an angle phi with horizontal. So tan phi is 20 by Fs. So putting the value of Fs as 15. So we get 5 4s are 20, 5 3s are 15. When tan phi is 4 by 3, we know phi is 53 degree. So let's see the answers. Friction comes as 15 Newton and phi is 53 degree. So can we see any option over here? Yes, 53 degree above the horizontal. This is correct. So this one. And next, frictional force between the block and the floor is closest to, it is 15 Newton. So 15 Newton friction and 53 degree angle. I hope it is clear how in massive rope tension varies from point to point, and in that case if there is a continuous variation, how we can find the tension varying from T to T plus dt when we go by a small change in height or small change in length. So when we equate the forces, we get an expression between dt and dy. Integrating, we get the relation between the or the difference between the tension at the highest and the lowest point. And when we put the or substitute the values of TB and TA, we get the value of Fs. Once we know Fs, we know the angle also. So I hope this question is clear to all of you and you found this also interesting. So stay tuned for lot more videos to come, and do subscribe and share with your friends. Thank you.